But we're going to get started with our first presentation of the day from our global sponsor, Sandvik, which is, of course, a leading OEM in the mining space. Representing Sandvik today, we have Harold Jonker, Underground Drill's Business Line Manager. Harold, take it away.
Yes, thank you, Alicia. I'll just turn on my video if I can find the right button, and hopefully you can see me now. And good morning to everyone. Can you hear me okay, Alicia?
I can hear you great, Harold.
Perfect, thank you. And thanks to your team also for putting on the Supplier Symposium with a great agenda. I'm happy to be here on behalf of Sandvik as a global sponsor to talk about ReImagine mining and the mine of the future and the electric future. So I'll take it away with the presentation, which is in front of us here. So over the coming years, we at Sandvik, we see the uptake of battery electric equipment in mining increasing significantly. In already the last 1 to 2 years, electric power equipment in mining and many industries, it's gained a lot of momentum. We believe that electrification will be one of the biggest technology shifts in the conservative mining industry for a very long time. Now this will evolve, and the demand for these machines, they will go up over the next few years and will become a major part of what we do as an industry. Switching to the next slide, why electrification and what are the benefits? There's been a fair bit of work and chatter in this space, and these benefits are no real surprise to us, but the three ones that are here on the slide. The first being health and safety benefit, removing diesel particulates out of the mine. And in addition to that, the reduction in temperature for the miners as battery electric equipment gives off less heat. And this is especially critical for the hot mines, especially at depth. Then there's also the economic benefits, the reduced cost in ventilation, because with less heat, you need less ventilation and less cooling. And then lastly, but more importantly perhaps, is a sustainability benefit, the less fossil fuels, a reduction in fossil fuels and the greenhouse gas emissions. Now, I've been fortunate to have joined Sandvik Canada a little over a year ago after spending a decade in Australia, where I was supporting drilling automation projects. I inherited a healthy install base of battery electric equipment, as you can see on the screen here, and I look forward to supporting the industry making the switch to electric propulsion. On my arrival in Canada, I supported the change management process to introduce the battery electric automated bolter that you see on the screen here. 60 kilometers trammed, 2-minute automated bolting cycle to deliver 6-meter round in about 3 to 4.5 meters. So introduction of battery electric equipment, the change management process, working with the mines department in BC together with the mine to understand the challenges. Great project, and happy to see that it completed its site acceptance test. Moving on to our Borden Lake drills, where we have a development drill and several development drills, I should say, and our long hole drill, so 4,000 kilometers trammed. And these drills have been there since approximately 2017, so for about 5 years. And over that time at this site, 1.5 million meters drilled and 0 emissions. Now, Luke was the former project manager on site. He expressed he impressed that he was impressed with the minimized components. The reduction or elimination of diesel engines also means no more oil changes. And being a battery electric and onboard charging, no external charging stations are required as well. So moving to a different product line, I am from the underground drills team, but also from the load and haul side at New Afton. We have the battery electric LH518B loader. In addition to 0 emissions, this loader delivered on productivity, with improved mucking time from 9 minutes to 4 minutes compared to the diesel equivalent. And then rounding out the battery electric equipment, we have the Z50 battery truck at Pretium. And this showed that battery electric power, it definitely is a game changer. In addition to not only zero emissions, it smashed the productivity on site with 42% more tons and 22% faster than the diesel alternative at or on a 15% grade, and with a speed of approximately 9.5 kilometers per hour. So from here, I'll just run a video on some of our battery electric equipment. Hopefully it comes through and it is playing as well. Just bear with me for a minute as I switch that across. Is that still streaming through okay there on your side, Alicia? I assume it is.
Yes, it is. It looks great.
Yeah, cool. So what I'll talk about while the video is playing is a bit more about the savings and the future of the battery electric equipment. And then I'll switch to any questions the audience might have for the last few minutes of the presentation. So yeah, battery electric equipment, it gives major CapEx savings for an operation. You can build smaller tunnels because the size of battery electric equipment can be smaller with the same capacity. You can install less ventilation, which requires less cooling. And with the OpEx savings, fuel is cheaper. Trucks and loaders, they move faster, so they can move more tons. Now, if you compare electric equipment versus the traditional diesel equipment today, and if you compare the CapEx and also the OpEx, if you look over the full life of the machine, already today, they're on par with each other. Yes, the CapEx, it's higher for the electric, but for the OpEx, it's lower, and the energy, based on the energy and the maintenance costs. Now, when you factor in the savings the mine makes on ventilation and cooling, now there's a strong business case for going electric. So electric equipment, it's exciting. It's exciting because we have the opportunity to change the environment, both locally at the mine, but we can also change it globally. The swappable battery on our load and haul equipment, that's exciting as well. I don't have it playing on the video because this is from the underground drills product line, but the swappable battery, I'm sure you've seen or heard about it. It's just a very practical way of implementing something that's completely new into a mine. And the torque with electric power on these units is just massive. So Sandvik is championing the battery electric equipment in mining today. We have the widest range when it comes to the offering of battery electric products, both for underground drills and for loaders and trucks. We have the most advanced battery equipment with battery swapping technology that nobody else has. And we see and we think that in the next 2 to 3 years, every large contract will have electric equipment as a part of it. So electric equipment, it has clear potential to be better than the equipment we've had up until now. We've definitely seen that through the various trials and the machines that we have day in and day out at production at mine sites. Now, just to wrap it up, I want to reference Henrik Arger, our president, and he summarized the pull from the mining industry on battery electric equipment. What customers expect from battery electric equipment, they expect it to be as reliable or better. They expect it to be as fast or better. And they also expect it to be the same price or better. And so with that, I'll say thanks for the opening address and happy to entertain any questions in the remaining time.
Thank you so much, Harold. We do have some questions coming in. The first question is from Jennifer. How often do you need to do truck rebuilds with electric?
That does vary based on, I guess, the usage and the at the mine and also the profile, the ramp, and the loading of the truck. And I would say, being that I'm a drills guy, I cannot give the exact answer, but I'd be happy to defer to Brian Huff, who appears later in the panel. I'm not sure if it's on point, but happy to take that question offline, Jennifer, and help you where we can with a cost model to support any studies. And to support that, we're happy to bring in our transfer mine team as well. So appreciate the question.
Yeah, we'll make sure to connect you with Jennifer to get her that answer.
Thanks, Jennifer.
We have a second question from Luke. For remote locations without grid connections, what is the net efficiency after running the generators to charge the batteries?
the net efficiency using a battery electric drill, I'll defer to some of our engineers to get you actual numbers. But what we have found with the power compensation on the drills with power networks, and especially when there's poor power at the site, that it acts like a capacitor, and it's like a bank that can feed back into the mine when it's not using that power to tram or to drill. So there are definitely efficiencies realized that way, but to actually give you the net efficiency, I'll have to go back to you as well on that one.
Sure. We have another question. I'm not sure if you'll have the answer to this, but
Yeah.
What impact does it have on the ventilation companies? And he's asking about fans.
Yeah.
And I know that obviously you work with other vendors, and there's a lot of collaboration happening in the industry. And can you shed any light on that?
Yeah, we've seen and feedback from the sites we've been engaged with the full battery electric from the beginning, and there are a couple of projects coming online, but the numbers, and they're specific for every site as well, depending at what depth in the rock temperatures. But we've seen significant reduction in the ventilation, but also keeping in mind the cooling. The exact numbers there, again, I would say it's relative to the mine, and happy to support studies together with ventilation engineers to size projects as required. But we've definitely seen significant reduction. Yeah. And driving the reduction in costs then too, which makes it a game changer.
Great, thank you. And lots more questions coming in. Here's another one. How long does the battery of your equipment last operating in an underground mine?
That's a good question. So we've just released a new battery pack with the 4 modules. And the rule of thumb from the Sandvik underground drills, and I'll just talk on the underground drills. That's my area of expertise, and happy to engage, with full studies and also load and haul cycle times. In terms of batteries, for most of the mines, and especially here in Canada, where there's both ramp and shaft access, a rule of thumb is 4 kilometers per battery pack on a 1 in 7 decline. And so that's a very healthy tramming distance where we can supplement that, between shift change should it need to come out of the ramp. But yeah, the 4 kilometers on a 1 in 7 decline is a rule of thumb. Yeah.
And this is a great question that I'm sure a lot of operations across the world have asked you and gotten your input on. Is it economically feasible to retrofit an existing mine?
That's a good question. And it depends on also the fuel and the power source at the mine. So that I would say yes in some cases, no in other cases. And we've definitely had that feedback as well from brownfield sites. So is it clean energy? Does it come from a hydro dam? Is the power source on hand for the power, or is it diesel, remote site? And then also what depth and what ventilation it currently is in place. And if that is replaced, what is the savings? So I would say it's a yes and no answer, and site specific again.
Mm-hmm.
Yeah, but definitely, there's big gains to be had.
Another great question. How will electrification impact on the maintenance skill set at mines?
Very good question. And from what we've seen, we've recently introduced the CAN bus systems across the underground fleet. So whether it be a loader, haul, truck, and drill, so that's already stepped up the competencies in terms of troubleshooting. And what that's also allowed us to do is, with batteries as service, monitor the batteries and support either on-site or remotely with skills from Sandvik and supporting sites and upskilling the maintenance. So with batteries, there's a big reduction in mechanical components. So the maintenance is less in terms of the diesel engine maintenance. And we have seen evolving a different skill set within the maintenance teams, but it's not to a level where we can't find the skill set. So the colleges, they've also come behind us, and we've supported them where we've needed to with the change management process. And yeah, it's a very exciting transition, and happy to be part of it.
Mm-hmm. Are electric drills any quieter than diesel powered drills?
Essentially, when an electric drill is tramming past you, all you hear is the road noise as a tire hits the ground. And so you do hear it when you're next to it. But from that perspective, I would say it's very quiet. So yes, it is quieter. to a point where at some sites we install timing alarms. I would say timing alarm, they're standard, but without that timing alarm, yeah, you wouldn't know what's coming around the corner. So definitely quieter.
Here's a more complex question. What aspect of the Z50 truck has the BC Ministry of Mines approved? In other words, how are they equating BEV ventilation requirements to current diesel requirements for airflow?
That's a very good question. And what does that calculation look like, and or does it go away altogether? That's a question I'll have to defer to Brian. I won't even try to attack that one.
Sure. Has there been any impact on tire life on electric machines versus diesel?
Was that first part question relating to increased life on battery versus electric?
Any impact on tire life?
Oh, tire life. Yes, there is. And especially with the load and haul, I've heard reports on how the design also going to battery electric has increased the tire life. In terms of the percentage increase, I don't have that detail ready and available myself. No.
Okay. Yeah, we're sorry about this. We're just, I'm floored by how many questions you're getting here.
That's right. Happy to take them offline too in terms of timing.
Yeah.
Sure
No, we have more time for sure. Let's see. The next question is, how often is the average recharge cycle? So I'm not sure if that means how fast is the average recharge cycle? Maybe you can speak to that.
Yeah, so I can definitely speak to that from the drill's perspective. While it's at the face for the 2.5, 3 hours drilling the face, or if it's production drilling, it's charging while it's drilling. So the entire premise is that the battery electric drill, in terms of the operation, is no different than a diesel drill when it goes to the face. You plug it in, you do your round, you unplug it and you leave. And while it's plugged in to the let's say here in Canada, it's about 600 volts, it is charging that battery. So you unplug and then you're ready to go right to the next phase, 4 kilometers or up to 20 kilometers away if it's on a level heading. So no difference there. So 2.5 hours gets you, let's say 50 to 60%, sometimes up to 80% charge, depending how long it's at the face. So it takes the time for that drilling cycle, then it's ready to go again. Now for the load and haul, as I've referred to, it's a battery swapping process. So that battery is sitting there, and depending how many different units are using that battery swap bay, that'll change that charging time too, and the cycle time and the number of batteries required in that loading bay. So the idea is that when that unit requires a battery, it swaps, and that's a 5 to 10 minute process approximately, and it keeps moving. So the change out time for that battery is very, very short.
Okay, we just have time for one more question, and but we will get back to everyone else who has a question after the event. Let's see, a question on maintenance costs of electric versus diesel operated equipment. What is the savings there?
What is the savings? Depending on class machine and operation again. I'd rather not talk numbers and percentages, especially outside, with the load and haul. With the underground drills, I'll say a bit more on that. If you look at underground drill cost and the maintenance required in the consumables, I would say 90 to 95% of that is typically on the front end of the drill, the drilling module, the wearable components, and a very little bit, just a small wedge of the pie, is for the engine, or in this case, the battery and the driveline. So changing out from an engine to a battery driveline is pretty much insignificant when it comes to, when you look at the overall operating costs of an underground drill, which is the beauty of reviewing, one versus the other. And the question, we're often asked is why would we go diesel in the future for a drill? And so, yeah, it's exciting. A place to be in the industry.
Well, thank you so much, Harold, for that presentation and for answering all of that barrage of questions that our audience had for you.
Not a problem, Alicia. I had to defer a good number of them too, so happy to engage with them offline with the experts as required.
Great, thank you so much.
Yeah, thank you.